Hey folks, it's Mr. Ray here with our next lesson in grade 11 University Math. We are working in the Functions and Transformations unit, and we're going to be doing an important lesson today about how to basically take any equation that's transformed from a base function and be able to quickly graph it. It's something called base point transformations. So a couple definitions here. Function and mapping diagram. I'm going to show you mapping in a slightly different method here in terms of how we use it. Now the last 4 lessons we've been talking about the 5 different base functions. Then we got into the different types of transformations and the parameters we use. We talked about translations first, and then we talked about stretches, compressions, and reflections, and the parameters that went with them. Then in the last lesson, we actually combined all those types of transformations together using the parameters A, K, C, and D, and we started creating first of all, we did a description of what actually the transformations were, and then we used those descriptions to step by step we created the new version of the transform function. Now, if you remember from the lesson, the process that we did was a pretty laborious process. We did a quick sketch of the base function. Then for every transformation step, we applied what the transformation did to those base points, and we came up with a new version. Then we went to the next transformation step and applied those changes to the previous graph. And if you've got lots of stuff going on, you may have up to 5 different sketches of graphs. If nothing else, it's a very busy looking process. It takes a long time, and based on the way I was doing it, you could see that it's not the most exact way of creating your final graph. Lots of possibilities of making mistakes along the way. So today should be a breath of fresh air. I'm going to show you an approach. Instead of doing multiple graphs of basically each transformation step, we're going to put all the transformations together and modify the base points once with all the transformations at the same time, and we'll create some transform base points, plot those, and then we have our single graph that we can then sketch. So let's get down to it. We've got a review here. So we talk about each of these bullet points is a different parameter, A, K, C, and D. So let's go through these just so you understand. Transformation parameter A describes the vertical stretch, compression, and reflection. This transformation takes the base point and multiplies the y coordinate by A to get the new transform point. So that does, the stretch the stretch or compression, and possibly if there was a reflection, it does that in one multiplication. So if the xy was your base point, how would we get the new transform base point based on what A is doing? We keep x the same, and we multiply the y coordinate by A. So this is the mapping I'm talking about. We're basically taking that base point and we're mapping it to a new transform point. Okay, so that's what the parameter A does. Let's go down to K. So the transformation parameter K describes the horizontal stretch, compression, and reflection. This transformation takes the base point and multiplies the x coordinate by 1 over k, very important, to get the new transform point. Okay, so if we were starting with just the base point, x, y, what do we do to it? We multiply the x coordinate of that base point by 1 over k. And that gives us, if we did this to all the base points, we would be applying parameter k, the horizontal stretch, compression, and reflection. Okay, now we're going to C. So the transformation parameter C describes the vertical translation. This transformation takes the base point and adds the C value to the y coordinate to get the new transform point. So if we're just doing the effects of C, we would take our base point x, y, and all we do is we add C to the y coordinate. Okay, and similarly for the D parameter, that's the horizontal translation. That's affecting the x coordinate, horizontal, left, right. So this transformation takes the base point and adds D to the x coordinate to get the new transform point. So you take the original base point x, y, and all we do is we add D to the x coordinate. We don't change anything with y. So this is kind of what we were doing when we did the step-by-step approach. We would do the A and the K transformations, and then we would do the C and D, the translations. Now, what's stopping us from doing all of this in one step? There's nothing stopping us. So what we're going to do is we're going to apply all 4 of these mappings. So we're going to still start with X, Y, and combine all of these changes to X and Y. So if we put all those together, X, Y, the base point, maps onto, or the transformation gives us 1 over K times X plus D. So that's the brand new transformed X coordinate for the given base points you want to change. And then the Y coordinate, we multiply it by A and add C, so AY plus C. So this is a very important formula if we're going to quickly graph using base point transformations. So we're just going to do 2 of these, and then you're going to get lots of practice. So it's not an overly complicated process like the last lesson seemed to be. So given the base function f of x equals x squared, the transformation parameters a equals -1, k equals, I think that's should be equals -0.5, and c equals 2, d equals 5. Let me just rewrite that. K equals -0.5. So they're actually, in this question, they're giving us the values of a, k, c, and d. And the question we're going to do after doesn't. You have to figure those out yourself. So this is kind of skipping a step that you would normally take. So they've told us the original base function. So the first thing we do is we write the table of values of the base points for f of x equals x squared. So we've got x, and we've got f of x equals x squared. And these are the points that we used them last lesson and the previous lesson, and we also defined what these points were in the base function lesson. I believe that was lesson 3. Okay, so if you remember, the x values we used were -2, -1, 0, 1, 2 for x, and then we square those, we get 4, 1, 0, 1, 4. So those are the base points. Okay, and we're going to transform these base points directly to the final points. Now, what I usually like to do is, along this arrow, is write the values so I don't have to go back to the question. So I've got a equals -1, and I'm going to separate them in this for a reason here. I'll just write them first. I've got a equals -1. I've got c equals 2. I've got k equals -0.5, and d equals -3. Okay, and the reason why I'm doing that, the a and the c will apply to the y coordinate, and the k and the d applies to the x coordinate. That's the only reason I split them out like this, but I would write them out here anyways, just so you can see them very, very clearly, and you don't have to go back to the question. Now, here are the formulas. If you remember from the first page, I had this mapping of the base point to the transform point, so 1 over kx plus d and ay plus c. I'm going to put those above here just so I remember what to do. Now, even if you remember what to do, it's not a bad idea, just so you don't forget something, especially the 1 over k instead of k. And then the y coordinate, the new transformed y coordinate, will be ay plus c. Okay, so one other note here, just remember that that 0, 0 point on our base points was the vertex. So whatever we have, let me do my lines here, 1, 2, 3, 4, 5. Now inside the top line where I define what's going on here, this is where I actually replace A, K, C, and D with the actual numbers. So I get like a little formula for the transformation for that coordinate. So 1 over k, so remember k is negative 0.5, so that's like negative 1/2. If I flip that upside down, it becomes negative 2. So it's going to be negative 2x. The x I just leave as. We're going to see how we use that in a sec. And then it's plus d. D happens to be negative 3, so it's minus 3. So negative 2x minus 3, that's going to be the formula I use to get my new x coordinates from my base points. And I do the same thing with this generic formula, ay plus c. Well, a is negative 1, so that's negative y. And then plus c would be plus 2. Okay, so we're all ready to go now. What we're going to do, I'm going to start with the original base point x coordinates, and I'm going to apply this formula here. So I'm going to multiply it by negative 2 and subtract 3. I'm going to do all 5 of them and then do the y's later. So if I plug in negative 2 here, I get negative 2 times negative 2 is positive 4, minus 3 is positive 1. And then I plug in negative 1 where the x is. So negative 2 times negative 1, that's 2. 2 minus 3, that's negative 1. Do the same thing with 0. Well, anything times 0 is 0. Then subtract 3, I get negative 3. And then 1, negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. And finally 2. Negative 2 times 2 is negative 4. Minus 3 is negative 7. And take a little note here. There's a distinctive pattern here. These values are going up by 1 each time. Sorry, up by 2 each time. And that's, down by 2 each time. Decreasing by 2. And that has to do with what we're multiplying by. The negative 2 will dictate the pattern that you should see here. Okay. Now we're going to do the transformed y coordinates. Now you have to be careful here, and I'm guilty of this mistake quite often. Usually when you're calculating your y value, you're thinking, oh, I'm going to take the x value from here and apply the formula. Well, that's actually wrong for this technique. What we're actually transforming are these y coordinates over here. So I'm going to plug these y coordinates into that y value there to get my transformed y value. So in the first case, y is 4. So negative 4 plus 2, that's going to be negative 2. And you can save yourself a bit of time here because there's actually 2 y coordinates of 4 in the base points. So that point at the bottom, that's going to have the same value as this point. So that's going to be negative 2. Okay. If you do the calculation again, no harm, but it is a time saver. Same thing with this. You can see I've got 2 y coordinates of 1. So I can just copy that result. So I plug in a 1, negative 1 plus 2 is 1. And I'm going to use that again down here because that's also starting from the same point. And then finally, I've got a 0 here. So I plug that in. Negative 0 plus 2 is 2. So there's my transform base points. And again, you can see we know that middle point was the vertex. Well, this is your vertex as well. And notice what the actual value is. This is your value of D and C, because that's how you're translating. Okay, it's always going to work out that way. So now all we do is plot these 5 points and then finish our graph. So I like to start with the vertex. for the quadratics, which this is. So negative 3, 2 is going to be negative 3, 2 right there. And then I've got these two mirror points. So I've got negative 1, 1, which is here, and negative 5, 1, which is here. And then I've got my two outside points. So I've got 1, negative 2, and negative 7, negative 2. Make sure I get the right. Sorry, that's negative 6. Okay, so there's my 5 base points. I know that's the vertex, which you should be able to tell anyways. So when I'm sketching this, I like to draw a little cup here where the vertex is going to be, and then start sketching. Now, there's a little bit of guesswork here because there's no points down here or over here. So just do your best job. Try to make this look symmetrical. I'm not going to take off any marks if you're not artistic, but just try to make it look as clean as possible. Do your best. So I'm going to label this now. That's the function g of x, and we're done. So wasn't that a lot nicer than what we did in lesson 6? This is a little bit of calculation here and one graph of 5 points, and we're done. Okay, so let's try a slightly modified version of that. Like I said in the first example, they actually gave us the base function and the parameters a, k, c, and d, and that's pretty ideal because the f of x tells you which base points to use, and these values tell you what do we do with those base points. So more realistically, you would be getting a function g of x, which has got all the transformations built in, and it's going to be our job, first of all, to identify what the base function was, and hopefully, when you see a function like this, the base function could be one of 5, and 4 of those base functions are pretty obvious. They've got a certain identifier that tells you what it is, and this one's probably the most obvious. You see a square root in your function, in your transform function. You know that the base function was f of x equals square root of x. Or if you saw something being squared, you know it's x squared. If you see absolute value lines, you know it's the absolute value of x as your base function. And if you see if your x is on the bottom of a fraction, you know it's 1 over x. So you do that first, and now we're going to actually grab the parameters from the equation. So a, k, let's do them in order here, d and c. Okay, so this is a skill that you need to develop. Now the fact that the square root symbol surrounds x plus 1, well, your k and your d values would be inside that square root, and your a and your c values would be outside the square root. So based on that, I know that the a value is negative 2. I know that the c value is positive 3. I look at inside here, and I don't see anything multiplying with the x. So that tells me that, well, I can't see a k value, but by default the k value would be 1 since it's multiplying. And that's an important thing here. If you don't see the value, you have to put the default. So the default for anything multiplying, a and k, if you don't see a value, the default for a and k is 1. If you don't see a c or d, the default is 0 because you're adding that value. Okay. So since I don't see a k value, the default is 1. I do see something being added, but remember the formula, it's x minus d. So that, remember, d is a little quirky. So d is not positive 1, it's negative 1. Okay, now we're off and rolling. We basically got the same information that was given to us in the previous one, but we had to do a little bit of preparation work to get it. So in this case, the base function is square root of x. So I've got x and f of x equals square root of x. And remember, we had 4 points for this. We had all perfect squares down here so that when we take the square root, we get a nice integer 0, 1, 2, 3. So those are our 4 base points. Remember that this point here, that's our end point of the square root function. The graph actually ends at that first point. So whatever it transforms to will be the end point of the transformed function as well. Okay, so we're going to transform these. Now, okay, so I'll do the same thing I did before. So the A and the C values I'm going to put here. So that's -2 and 3. The K value is 1 and the D value was -1. So I need to develop little mini formulas for what I'm going to be doing to the original X and Y coordinates of the base points. So I won't write it again just because I can see it up here. So it's going to be 1 over kx plus d here. So 1 over k, 1 over 1, which is just 1. So it's just going to be x plus d, and d is -1, so it's x minus 1. And then I go over to create the formula for what are we doing to the y coordinates. It's going to be ay plus c, a times y plus c. So a is -2, so it's -2y plus c, which is 3. So there we are. We'll just put some lines here. Okay, so now it's just a matter of taking our original applying the transformation formula that's given here. So we take our original x value. So x equals 0. 0 minus 1 would be -1. When x is 1, that's a 0. When x is 4, that's a 3. When x is 9, that's an 8. Okay, so now I'm going to go back and plug in the y values from this column and into this formula. So -2 times 0 plus 3, that's going to be 3. -2 times 1 is -2. -2 plus 3 is 1. Then we've got a 2 value there. -2 times 2 is -4. -4 plus 3 is -1. And y value of 3, -2 times 3 is -6. -6 plus 3 is -3. Okay, and these are the only points I need to plot on this graph. So let's start at the top. -1, 3 is right here. And if you remember, that's the end point. So these points will join, connect to these. 0, 1. 3, -1. And 8, -3. Okay, so I've got those points there, and it's important, like I said, to know in this case where that endpoint was, because you might think it could be here, but we transformed the endpoint here to become the transformed endpoint, which is here. So my curve actually starts here and sort of makes a nice curve over here with the arrow on this end, because that actually keeps going. I could have put some more points, but these were enough to get the shape. Okay, and then of course label the graph. This is our graph of g of x. And again, a very quick process, especially after you've done it 2 or 3 times. Just a matter of starting, get your base function, get your values of a, k, c, and d. Remember your base points for that base function, and then it's just remember those transformation formulas, these ones here, so that you can create your mini formulas for x and y coordinates. Then you just create your transformed points using those formulas and plot them, and you're done. So I think it's an awesome way of graphing what looks like a really complicated, like if you looked at that and I asked you what does that graph look like, you probably wouldn't know. There's a lot going on there. Now the question I get, and it's a legitimate question, why bother going through all this process? Why don't we just do a table of values for this function, plug in some values, get some points, and do our graph? The problem with that is you might pick some x values that you think are reasonable, but they might not even exist for that function, or they won't give you enough information to be able to do a good job sketching. And you notice when we actually created our base points, when we got our transform parabola, we had 5 points. The middle point was the vertex, and then we had 2 points on the left, 2 points on the right. That gave us the shape of this parabola. If I just maybe randomly pick some points like x equals 1 through 5, I would get some points down here. I'd have no idea where the vertex was, and I would have no idea what the shape of the graph looks like. So the fact that we're using these base points that are strategically given to you to define the shape of the base graph, though that shape gets transformed over here so that you don't have to go back and pick any additional points. You know exactly what that looks like. Same thing with this graph. We included that endpoint 0, 0. So when we plotted our points, we knew nothing goes beyond that point, and everything goes through that point and beyond. Okay, so that's the reason why we just don't do a table of values and pick some random x values. If I pick some negative values for x for this, I would get like no points, because I'd end up taking the square root of something negative, and I get very frustrated and keep trying other points. This is a much quicker graph. At the very most, we're plotting 6 points, anywhere from 4 to 6 points, and those 4 to 6 points will give you a really good idea of what that transform graph looks like. So the homework questions for this, this is not a typo. This is the handout from lesson 6, the previous one, where I gave you a bunch of transformed base functions, equations for them, and I asked you to graph them using the technique we learned in lesson 6. And now I'm saying, okay, we know that technique isn't all that great. Let's try this new and improved technique that I think you'll like better. So it's basically print that handout again, and this time use base point transformations. Okay, and on any test I give you, I will be asking you to use this method specifically. So when I say graph one of these functions, I'll be saying using base point transformations. So I'm relying on you to know how to use this technique. If you just pick some random points, you're going to lose a lot of marks, because I've specifically said using a certain technique. If you don't use that technique, you're not showing me what you know about that technique. Okay, so that's it for today. There's one more lesson for this unit, and that's looking at inverse functions. So until then, have a great day, and we'll see you on the next lesson.